So we start right back at the basics then, because how do we communicate maths? Algebra obviously is one of the ways. There it is. The rule that we live by. Like terms can be added or subtracted, unlike terms cannot. I don't think I bothered with any examples there on that one, but that's basically so, because a term, if you like, in algebra is an unknown. It's something that is unknown. So you can't add different unknowns because you don't know what they are. Okay? Now, if you've got two of the same unknown, I still don't know what it is, but I know I've got two of them. And so that's why you can go x plus x is 2x. We still don't know what it is, but we know we've got two of them. Then we have these wonderful laws, the index laws. It's important we follow them. Multiplying, add the powers, of course. Divide, subtract the powers. When we have the parentheses situation, that's when we multiply the powers. And of course, the lie that we always tell you, anything to the power of 0 is equal to 1. Yes, it's a lie. It's not true. Go on, give me a counter example. Anytime you can give me something that doesn't work, it means it falls apart. And you can certainly find a counter example for that, where it's not true. Anyone?
0.
Yes. 0 to the power of 0. Well, that's not 1. What is it? What do you think it is? Infinity, did you say? Oh, there. Yeah, so that's the problem. 0 is like this really weird number. In fact, some people say it's not actually a number. It's just something we use to represent the lack of value. So it does weird things. So 0 to the power of 0, some people say, oh, it's got to be 1. Anything to the power of 0 is 1. No, it's got to be 0, because 0 to the power of anything is 0. And the answer is it's just undefined. We don't have an answer for it. We don't know. We don't know what 0 to the power of 0 is. Try it on your calculator. You'll come up with an error. It won't do it. Right? So it's not actually true to say anything to the power of 0, because there is that one exception. But it is a minor exception, so we do get away with it. But what do these indexes actually mean? Like when we start maths, we give you really basic definitions. And so with powers, we might have said, oh, it's how many times you multiply the thing by itself. That was great when you're dealing with positive whole numbers. But then you got to negative numbers. And you went, oh, x to the power of -2. I'm going to multiply it by itself -2 times. It doesn't make sense. So what do they actually mean? So positive, the way I think of a positive, it just simply means top of the fraction. This goes on the top of the fraction. A negative, this goes on the bottom of the fraction. It's like a little instruction. See, positive, top of the fraction. Negative, bottom of the fraction. A better way possibly of saying it is same side or other side, because if you have something to the negative power on the bottom of the fraction, then it should actually go on the top of the fraction. So it should change its sides. But if it's got a positive power, it stays on whichever side of the fraction it's on. And then you have these fractional indices. That makes even less sense. You multiply it by itself a half time. Well, so I just see half of the letter x? I mean, what goes on there? The top of it tells you the power. The bottom tells you the root. It's as simple as that. So the top of the fraction tells you the power, the bottom tells you the root. So you see something like that. It's the bth root of x to the power of a. Or alternatively, you could write it as the bth root of x all to the power of a. Now, personally, how would I write it? It depends if I'm dealing with x or if I'm dealing with an actual number. If I'm dealing with an actual number, I'll do the root first, and then I'll go to the power. But if I'm dealing with algebra, I'll go the other way around. I'll always go the bth root of x to the power. Main reason for that is, if I'm dealing with an actual number, if I find the root of a number, it makes it smaller. And it's always easier to raise a smaller number to a power than find the root of a bigger number, if you get what I mean. So rather than find the root of the bigger number, I'll find the power of the smaller number. It doesn't really matter. So I see x to the -3, and they, typical sort of question, rewrite this without using any negative or fractional indices. The negative is an instruction. I'm on the bottom of the fraction, and the 1 there, of course, is implied because as the coefficient. So it's to the power of 1, which is positive. It goes to the top of the fraction, 1 on x cubed. So I get a mixture. Oh yeah, A goes to the top, B7 goes to the bottom. Oh, whoa! We love doing this in maths, don't we? Try and make the question look harder. It's exactly the same. You just follow the same principles. They've even answered the first bit for me. They've written 3/4. Well, we know the 3 goes to the top, the 4 goes to the bottom. Then we go, well, x, that goes to the bottom. The A, that goes to the top. The B, that goes to the bottom. A power of a quarter. Well, top tells me the power, bottom tells me the root. 4th root of x. In fact, whole numbers are still the same thing. If I had x squared, that's still saying the same idea. The top tells me the power, the bottom tells me the root. Well, 2 is 2 over 1. We don't normally talk about the first root of something. It's a meaningless thing, because just like anything to the power of 1 is itself, the first root of anything is itself as well. So we can rationalise it that way. Why to the power of 2/3? Again, top tells me the power, bottom tells me the root. That's why I like to leave it there, because if I'd done it the other way, I'd have parentheses around the cube root, and I just think that looks a little bit messy. So I prefer to write it as the cube root of y squared. 3 on 2, the other way round, square root of x cubed. Now, that's how a mere mortal would leave the answer. Us super mathematicians look at that and go, oh, that can be simplified. We always simplify our surds, because that I could rewrite as x squared times x, and I know the square root of x squared, so it becomes x root x. Yeah? Just like simplifying surds with numbers. You're trying to factorise out a perfect square. Easy way of seeing it though. You have 3 on 2. You never write it as a mixed numeral, but think of it as a mixed numeral. So you see the 3 on 2, you think 1.5, and it's now telling you the answer. It's x to the power of 1 and x to the power of 1/2, but remember, we multiply x root x. You got it straight away. So you just look at it as the improper fraction and it tells you the answer simplified straight away. X to the power of 1 and x to the power of 1/2. Done. So if I, for some insane reason, wanted m to the power of 27 on 4, I go, oh, that's easy. 27 on 4 as an improper fraction would be 4's in the 27 goes, oh, arithmetic, eh? What's 4's in the 27? 6 with 3. So we've got 6 3/4. So it's m to the power of 6, and then m to the power of 3/4. M to the power of 3/4 would be the 4th root of m cubed. That's how you would simplify that particular one. You'd rewrite it without fractional indices. Piece of cake. Oh, test comes along, we just like to scare you. Do this one. Oh well, just do it bit by bit. Half's already done for me. 2's on the bottom. I'm not going to put the 1 on the top because I know some algebra is going to go there. So I don't have to worry about writing the 1. N goes on the bottom. P goes on the top. Q goes on the bottom, but 1 on 28. Well, 1 on 28, that would be the 28th root of Q. C goes on top. 7 on 6. That's an improper fraction. 1 and 1, 6. So I'd write that as C times the 6th root of C. And that just leaves me with R going on the top. Now, careful when you're writing your roots, because you could confuse that to be c to the power of 6 times the square root of c. So what we try to do, I guess the font in this isn't great, but that little number, that 6 should be inside the v of the square root sign, which of course is called the, anyone know what that symbol is actually called? It's a radical. Okay, so the radical symbol. So 6 should go inside the radical symbol. The 28, it's more obvious that it's inside the radical symbol there. But fractions. Fractions to a negative, you just turn them upside down and make it a positive power. Do you remember how I said the instruction for negative was, I'm on the other side? So now the 2's on the bottom and the 3's on the top. Okay, so 9 on 4. Alrighty, now. Exercise 1A, I actually photocopied off 8A and 8B and they're at the back of those notes because I wasn't sure when I put this together over the holidays whether we were going to give you the handouts for the first chapter or whether we were putting them on Moodle. So